Greetings to the viewers. My name is Paddington. So today we'll be doing mathematics, chapter 1, grade 11, which is exponents and sets. So I recommend the grade 12s to also watch this chapter. If you check here in chapter 1, you have exponents and sets. Chapter 2, we have equations and inequalities. So in grade 12, these chapters, they are not there. It only starts from number patterns and so on. So I recommend all the grade 12s to watch this video, as it serves as a revision, and to those who are in grade 11, it serves as a lesson. So let's start. Since we did the laws of exponents, today we'll be doing some exercises regarding those laws of exponents, the one we did before. So let's just start with exercise 1. Let's do 1a. So 1a, it's 5 to the power of 0 plus open bracket 5 to the power of 0 close bracket to the exponent 0, like this. So like we said before, anything to the power of 0, it is 1, plus anything to the power of 0. Can you see that this all this that is in the bracket, it is to the exponent 0, so the answer here will be 1. So I'm gonna say 5 times 1, which is 5, plus 1, which is, so I'm gonna say 5 times 1, which is 5, plus 1. So 5 plus 1 is 6. So this was easy. Let's go on 1b. Let's try 1b. So 1b, we are given, open bracket, negative 2 x to the power of 3 y squared, or all in the exponent 3, like this. So here what you do, you're going to check on this. Can you see that on x to the power of 3 there is an exponent, y squared there is an exponent, but then on 2 there is no n exponent, but then we assume that it is 1, like this. So from there we remove the brackets, and I said before that this bracket, it means multiplication. So what I'm going to do, I'm going to say 1 times 3 is going to be negative 2. 1 times 3 multiplied by the dot means multiplied by x. 3 times 3 dot 2 times 3, like this. From there we get our answer. 1 times 3, well, let us multiply the exponents. Negative 2, 1 times 3 is 3, then x 3 times 3 is 9, then y 2 times 3 is 6. Then from there we go further in x and simplify. A negative 2 to the exponent 3 is going to be negative 8, x to the exponent 9, y to the exponent 6. So this is our answer. So what I did here, we are going to write a negative 2 3 times. So it's going to be negative 2 times negative 2 times negative 2, like this. So it's going to be a negative, but a negative is positive. Then you say 2 times 2, that's 4, multiplied by negative 2, then 4 times negative 2, that's going to be a negative 8. So this is how we get our answer. So we have signs that we use when we are multiplying like this. So we have got a positive times a positive is going to be a positive, then a positive times a negative is going to be a negative, then a negative times a positive is going to be a negative, and a negative multiplied by a negative is going to be a positive. So this is what so these are the signs that we are going to do whenever I'm applying. So for example, e.g., let's say if you're saying let's use this one first. If you're saying 5 times 5, can you check that the 5 is positive and the 5 is positive? So we said a positive by a positive is equals to positive, so it's going to be 5 times 5, which is 25. Then come here, let's say we've got negative 5 times, let's say we've got a positive 5. Let's say we've got a positive 5 times a negative 4, and we said here a positive by a negative is going to be a negative, so it's going to be a positive times negative, it's going to be negative. Then you say 5 times negative 5 times 4, it's going to be 20. So let's come here, let's say we've got a negative 2 times 3 is because, can you see that negative by a positive is going to be a negative, so your answer will be a negative. Therefore you say 2 times 3, which is 6. Let's say we've got a negative 7 multiplied by a negative 7. We said that a negative times a negative is going to be a positive, so it's going to be a positive here. Then say 7 times 7 is going to be 49, but normally we don't write the positive, we just leave it as 49 like that. So we continue. Let us be quick. Let me check another one that is more challenging. Let's try F. Let's do F. So F, it says, open a bracket, 10 y to the power of 4 all over 4 y to the power of 6 to the exponent negative 2, like this. So what we do here, let me write it clearly actually. So it's we are on F now. So it says, open a bracket, 10 y to the power of 4 all over 4 y to the power of 6 close bracket negative 2. And I said that before, if you have got a fraction like this and it is all to the exponent negative 2, what you do is you switch. It means that what was on the numerator becomes on the denominator, what was on the denominator becomes on the numerator, like that. So this was our rule number 10 here. So we use this rule by switching. Can you see that A was on the numerator, B was on the denominator. Now B is now on the numerator and A is now on the denominator. So we switch. Then it loses the negative to be a positive exponent. So that's what we are going to do. So it's gonna be, before we do anything, we are going to switch these numbers. Gonna be 4 y to the power of 6 all over 10 y to the power of 4. Then immediately when we switch, it loses the value, the negative, and becomes a positive, like this. Then from there you check here, there is an exponent. There is no n exponent, you write 1. There is no n exponent, you write 1, like this. And then from there you say 4 times 2, which is 2. Then say 6 times 2, which is 12, all over 1 times 2, which is 10 squared, 4 times 2, which is 8, like this. So let us go to another page. So it's gonna be 4 squared, which is 16 y to the power of 12. So it's gonna be 16 y to the power of 12 all over 10 squared is 100 y to the power of 8. So it's gonna be 100 y to the power of 8. Then from there we simplify. Remember, we were asked to simplify, so here we are going to simplify. So a number that goes into 16 and into 100 without leaving a remainder, that's 4. Then 4 into 16, it goes 4 times all over. Then 4 into 100, it goes 25 times. Then it's gonna be y to the power of 12, y to the power of 8 here. So what we do here, whenever we are dividing, what we do to the exponent, we subtract the exponent. So it's gonna be 4 over 25 y 12 minus 8. which is going to be 4 over 25. Y 12 minus 8, that's going to be 4. So this is our answer. So whenever we are dividing, don't forget we subtract the exponents. So let's go on I. I think this one is more challenging. So I, we have x plus y all over x negative 1 plus y negative 1, like this. So what happens here, before we do anything, you are going to make this and this exponent to be a positive. Why? Because exponents, they are always positive. So whenever we see exponent being negative, we try to make them positive. Can you check here what we did? This was negative and we had to make it a positive exponent. So whenever you are having a negative exponent, let's say you had a negative exponent here, you are going to make it a positive exponent because we try to make all the negative exponent to be positive exponents. So from here, I'm going to make this exponent to be a positive one. Remember our rule, this one. I'm going to use this rule, this rule number 3, that says x negative n. So what you do here, you make this a fraction like this. So as it goes down, it loses the exponent. So it's gonna be, so what is left on top will be 1 to the exponent n. So it loses the exponent, it loses the negative to be a positive. So now it is now a positive. So what you do first, you make it a fraction, then you take this to the bottom. As you move it to the bottom, it loses the negative and it becomes a positive exponent like this. Then what is left on top, it is 1. So that is what we are going to do here. So now be x plus y all over 1 over x plus 1 over y. So what we are going to do here, we are going to solve this part. So for us to solve this part, what we need the lowest common factor of x and y, which is the denominator. We need to find the denominator, our denominator. So here we need to find the lowest common factor. So what we're going to do, we need a number or a letter that goes into x and into y without leaving any remainder. For you to make things easy for yourself, what you're going to do, you're simply going to multiply x times y. So x times y is going to be x y like this. So if you say x into x goes, how many times goes 1, it goes once, and it leaves y, then this y times 1, it's going to be y here, plus this y, this, then you're going to be, then this y goes, how many times into y? It goes once, then you'll be left with x, then x times 1 will be x like this. Remember, we did not solve this one, so it remains as it is. This one, it is a big division, so it's going to be x plus y. So this big line, it represents a division. So what we are going to do, we're going to say x plus y divided by y plus x all over x, y, like this. Therefore this one is a fraction, this one is not a fraction. You make it a fraction by dividing by 1. Then from there you're gonna say x plus y all over 1. So what we do here, you change the division into multiplication. So immediately when you change the division into multiplication, you invert. So whenever you are inverting, it means that what was on the denominator becomes on the numerator. What was on the numerator becomes on the denominator like this. So it's going to be x y all over y plus x like this. And then you can see that this and this are the same, therefore you cancel like this. Therefore you'll be left with 1 here. With 1 you can say 1 times xy is going to be xy all over 1 times 1 is going to be 1, which is the same as xy like this. So these things are the same. So let's let's try to do number 2. We're not going to do all the questions because there are many actually. So let's just try to do the questions that we think they are a bit difficult. So let's start with 2a, the one that is more easier. So it's gonna be it's 1 to the exponent 2010 all over 2000 2011 to the exponent 1, like this. So what happens is that, as I have said, that when you've got a 1 here and it is to an exponent, it can be a 2011, it can be a million, the answer will always still be 1. So this was our law. If you have yes, so this was our law. So check the example here. You can have 2008 and the answer will still be 1. So if you have 1 here and it is to the exponent to a million or a 2000 and what 2008 or 100, the answer will still be 1. So we are going to have 1 here all over 2011 to the exponent negative 1. So as I said that before, that we try to make exponents to be positive each and every time. So this exponent, it is negative, so let us make it a positive. So for it to be a positive, it has to be on the numerator. So it's going to be 2011 and it becomes a positive. So as it goes to the numerator, it loses the negative to be a positive. So it's going to be a positive 1, which is the same as 2000 and 2011, like this. So let's see. Let's try to do a D. It seems a bit more difficult. Okay, so let's do 2D. 2D. So it says open bracket 1 over 4 close bracket to the exponent negative 3 x multiplied by 8 to the exponent 2 minus 2x, like this. So from here you can see that we have got an exponent that is negative, and our law says that if you've got a fraction like this and a negative as an exponent, we switch this exponent again. This exponent, we are going to use this exponent number 10, this one. We switch. If a was on the numerator, becomes on the denominator. If b was on the denominator, becomes on the numerator, like that. So we are going to switch. So it's going to be 4 over 1. Then it loses the exponent to be a positive 3x multiplied by 8 x exponent 2 minus 2x. Then from there we remove the brackets, and whenever we are removing the brackets, it means this bracket, it means multiplication. Check here, there's no n exponent, I write 1. Here there's no n exponent, I write 1. Therefore it's gonna be 1 times 3x gonna be 4, 3x all over 1, 3x multiplied by 8 to the exponent 2 minus 2x, like this. And we said from our rule that if we have 1 as our base and 2 it is to the exponent any number here, it is always 1. So it's going to be 4 3x all over 1 multiplied by 8 to the exponent 2 minus 2x. Then from there, this is the same as 4 to the exponent 3x multiplied by 8 to the exponent 2 minus 2x. From here, what we do here, we are going to find the prime basis of 4 and the prime basis of 8. So what we do, you take your calculator, then you write the number that you want. So it was for the number that you want to change into prime basis, which is 4 in this case. So it's gonna be 4 equals to, then you write shift and fact. So it's gonna be so you write 4 equals to shift then fact, like this. So it's gonna be 2 to the power of 2 but since there is an there is an exponent, you open a bracket, then you say 3x multiplied by, you do that on 8 again, so it's going to be 8 equals to shift fact, it's going to be 2 the power of 3. Since there is an exponent, you open a bracket, then you write 2 minus 2x like this. Then from there you remove the brackets, you write your base first, then say 2 times 3 is going to be 6x multiplied by 2. Then this 3 is going to multiply 2 and negative 2x, so it's going to be 3 times 2 is going to be 6 minus 3 times 2 is going to be minus 3 times 2x is going to be 6x. From here, can you see that our bases are the same? So if we have the same basis, what we do is that we are going to rule number one, whereby if we have the same basis and we are multiplying, what we do to the exponent, we add the exponent. So it's going to be 6x plus minus 6x. So it is the same as 6x minus 6x, which is going to be a 0. Then you'll be left with 2 to the power of 6 like this. So it will be 2 to the power of 6. Then from there, what you do is that, remember, we are simplifying. Therefore, that's where you take your calculator, then you say 2 to the exponent 6, then you get 64 like this. So this is our answer. So we continue. Let's try to do another one, the one that is more difficult. I did D, let's try a G. I'm just doing the ones that I think are a bit challenging. So let's do D, 2G. So it's 1 all over 3 negative 1 plus 2 negative 2 like this. So what we do here, before we do anything, we are going to make the exponents to be a positive. So it's going to be 1 all over, remember we have our rule, this one, so we're going to use this rule. You make this one a fraction, then you take it on the denominator, or you take it to the denominator. So as it goes to the denominator, it loses the value and to be a positive like that one. Then on top it will be 1. So it's going to be 1 over 3 plus 1 over 2 squared. Then from there you solve this part only by finding the lowest common factor. So what you do, you're gonna do like this. So before we find our lowest common factor, it's going to be 1 all over 3 plus, let us simplify that. So 2 squared, it is 4 like this. Therefore from there we find our lowest common factor for 3 and 4, the number that can go into 3 and the number that can go into 4 without leaving a remainder. And what I said is that you're going to multiply these denominators to get a lowest common factor. So it's going to be 3 times 4, which is 12. Then 3 into 12 goes how many times? Goes 4 times. That 4 times 1 is going to be 4, plus 4 into 12 goes 3 times. That 3 times 1 is going to be 3. Then remember this one, it remains, it is 2 there, so divided by 1 like this. Then from there, what I said that is that this line, it means division, so we are going to say this 1 divided by, or before we divide, let me just come to this side. Before we divide this part, remember this part, before we divide, let me add this number. So it's going to be 1 all over 4 plus 3 is going to be 7 all over 12. Therefore from here, that's where you're going to say this line, I said it means division, so we're going to say 1 divided by 7 over 12. Then you make this one a fraction, since this is a fraction. So what you do here is that it's going to be 1 over 1. You're going to invert this side, so we need to change this division into multiplication. What you do is you invert, so it's going to be 12 over 7. So what was on the denominator becomes on the numerator. What was on the numerator becomes on the denominator. Then from there, we are going to say 1 times 12 is going to be 12. 1 times 7 over 7. So this is our answer. So this will be our answer. So our answer is 12 over 7, like this. So what I said I'm gonna say 1 times 12, which is 12. 1 times 7, it is 7. So when you get to this part, you invert your numbers. 12 becomes on the numerator, 7 becomes on the denominator. Let us see, and let us try the other one. This kind of thing we did it. Let us do E. So E is gonna be 8 is to 9 to the exponent 3 all over 32 squared 27. So what did you are going to find at the prime basis of 8? So this you're going to say 8 equals side equals to 8 equals to shift, then fact, like this. Then you get it to the power of 3 multiply by, then you do that on 9 again, shift fact, then you get 3 squared. Since we have an exponent already, you open a bracket, then you write your 3, then 32, we do that. 32 equals to shift fact, gonna be 2 to the power of 5. Since there is an exponent already, you write a 2 multiply by, then you go to 27, that'll be 27 equals to shift then fact, so it's gonna be 3 to the power of 3, like this. Therefore we remove the brackets, gonna be 2 to the power of 3 multiplied by 3 times 2 is gonna be 3, 6 all over, write the base. 5 times 2 is gonna be 10, the exponent 3 to the exponent 3, like this. So when you get to this part, we know that whenever we are multiplying, what do we do to the bases? We subtract the base. You can see this base and this base, they are the same. So what I'm going to do to the exponent is subtract the exponents. So what I'm going to do here, I'm going to say since I have this base and this base, they're the same, so it's going to be, I'm going to take one base, then I say 3 minus 10. Remember we are dividing, so whenever we are dividing, we subtract the exponent, multiply by 3. We're on this 3 now, you take this 6 minus this 3, then therefore 3 minus 10 is going to be 2, negative 7, multiplied by 3, 6 minus 3, that's 3. Then can you see that our exponent is negative? And I said that whenever you have got a negative exponent, we always try to make it a positive exponent. So from there, it's gonna be, you make this one a fraction, then you're going to take this and it goes to the denominator, to the denominator. So it's gonna, we are going to be left with 3 to the power of 3 all over 2 to the power of 7, like this. Therefore we simplify 3 squared, 3 to the power of 3, that's 27, all over 2 to the power of 7, that's 128, like this. Let me verify. 2 to the power of 2 to the power of 7, that's 128, like this. So this is our answer. Remember, we are all trying to simplify, so the point here, it is to simplify actually. What else? So we did not do this one, the one with a decimal. So let me do the last one with a decimal. So what you do here, so it's gonna be 2b. So I'm just picking randomly, like questions that I think that might be a bit difficult to use. 0.125 open bracket negative 3. So here, before we do anything, you can see that your exponent is negative, like this. So you try to make it a positive, so you divide by 1. So you take this one downwards, so it's gonna be, you'll be left with 1, so it's gonna be 1 all over 0.125. then it loses the exponent to be a positive. So this is our rule. This is our rule. Don't forget this rule number 3, this one. But still using it again. So from there you just gonna punch this the decimal 0.125 in on your calculator and you get 1 over 8. So it's gonna be 1 all over, you open a bracket, 1 over 8 to the exponent 3, like this. Then from there you find the prime basis of 8. So it's gonna be 1 all over, open bracket, 1 over, then prime basis of 8 is gonna be 8 equals to shift fact. So it's gonna be 2 to the power of 3. All in the L to the exponent 3, like this. So we remove the bracket, so it's gonna be 1 over. Remember this 1 over 2 to the power of 3. Okay. So what we do here, we know that on one, this one does not have any what is this, an exponent, so we write 1. Then from there we remove the brackets. So it's gonna be 1 times 3 is 3, but we know that since we have 1 is our base, our answer will still be 1. Okay, before we do that, let me write this one here, then I divide. Then I'm gonna say this 1 times 3 is gonna be 3, but since we have our base is 1, the answer will still be 1 all over. Then what I'm going to do, I'm gonna say 3 times 3, which is going to be 9, so it's gonna be 2 to the exponent 9, like this. So from there I said this line, it means division, right? If you still remember, so it's gonna be 1 divided by 1 over 2 to the exponent 9, like this, you see. Then from there you are going to invert this. So by inverting, so it's gonna be, this one is a fraction, you make it a fraction, divide by 1, multiply by, so when you invert, it will be like this. The denominator becomes the numerator becomes the denominator. It's gonna be 2 to the exponent 9 all over 1. Then from there 1 times 2 to the exponent 9 is gonna be 2 to the exponent 9 all over 1 times 1 is gonna be 1, which is still going to be 2 to the exponent 9, which is going to be, remember we are simplifying, so let us punch this number. So this exponent is going to be 512. So this is our final answer, like this. So this is how we do it. We're just playing around with the laws of exponents, so we have to know our laws of exponents. So here we were just applying our laws of exponent. So thank you guys for watching.